بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة التفاضل وهو مسائل على maximum value and minimum value of the function. Welcome my dear student in our math program for second 3. Today we are taking problems about maximum value and minimum value of the function. My dear student, look at the first example. Circular sector like cone, which area is 16 centimeter squared. A circular sector like cone whose area is 16 centimeter squared. Find the radius, length of sector circle which makes its perimeter as minimum as possible. What is the measure of each angle then? My dear student, look at the solution. My dear student, this is circular sector. What you mean of circular sector? Circular sector, this is part of a circle included between two radii and the length of arc. Angle between two radii is theta. Then circular sector has two radii and arc. The perimeter of circular sector r plus r plus l. Let the arc length of sector equal L centimeter and the radius of length of the circle is r. Perimeter of two sectors, perimeter of the opposite sector B equals 2r plus L. This is equation number 1. We know that area of a sector equal half LR from the first second, from given equals 16. Then what is the relation between L and R? L equals 32 over R. My dear student, by substitution in equation 1, perimeter to L plus R, we substitution about L equals 32 over R. Then what is the relation between perimeter and the radius? By differentiation both sides of this relation with respect to R. Then dy over dx or db over dr equals equal to negative 32 over r squared. My dear student, the second derivative equals 64 over r power 3. When, my dear student, dy over dr equals 0, r equals 4. Then d2y over dr squared more than 0. When r equal 4, the perimeter of the sector is as minimum as possible. Since, my dear student, area of sector equals 1 over 2 r squared theta rad. What you mean of theta radian? Theta radian from the first secondary equals length of arc over its radius. We have two measures of theta, theta radian and theta degree. What is the relation between theta radian and length of the arc, which opposite and radius? Theta rad equal L over R. We have area of sector equals 1 over 2 r squared theta rad. Then by using substitution about area, theta equals 16 times 2 over 4 times 4 equals 2 radian. Look at, my dear student, this summary, very important. First derivative test for the monotony of the function increase or decrease? First theorem, let f differentiable function on open interval. F dash x more than 0 for all value of x belongs to open interval a b. F is function increase. F dash x smaller than 0 for all value of x belongs to open interval a b. The function is decreasing on this interval. Critical point test. What do you mean, my dear student, critical point? F dash of x equals 0, f dash more than 0 at the left the point, or more than 0 at the right of the point, this critical point, or the function change from decrease to increase, or from increase, decrease, or increase. The function is continuous on open interval, has critical point, this point C and f of C. Fc belongs to open interval AB, and f dash C equals 0, or f dash C is not exist. What is the meaning of local maximum and minimum value, my dear student? If the function is continuous function whose domain is I and C belongs to this domain, the function has local maximum value at C if an open interval AB subset from the original interval I containing C, where f of x smaller than or equal f of C for all x belongs to open interval AB. Number 2, the function has local minimum value at C if an open interval is found in open interval AB subset from the original containing C, where f of x more than f of C, f of x more than or equal f of C for x belongs to open interval AB. First derivative test of maximum and minimum value. F is the point, this point C, and f of C is critical point for the continuous function f at C, and an open interval is found around C, where, my dear student, f dash x more than 0 when x smaller than C. F dash x smaller than 0 when x bigger than C. At the first, f dash x more than 0 when x smaller than C, and f dash of x smaller than 0 when x more than C. Then we know that f of C is local maximum value. Number 2, f dash x smaller than 0 when x smaller than C, and f dash of x more than 0 when x more than C. Then f of C is local minimum value. Look at, my dear student, this theorem. If we have function differentiable and the function has local maximum value or local minimum value at point C belongs to open interval AB, then we deduce f dash C equals 0. What is the meaning extrema value of function on closed interval? Extrema values of the function on the closed interval. Look at the theorem. If the function f is continuous on interval closed interval AB, then the function f has absolute maximum value and absolute minimum value on closed interval AB. Convexity of the curves. Very important rule. Convexity of the curves. Let the function be differentiable on interval AB. Open. The curve of the function f is convex downward if the function dash f dash is increasing on this interval, and convex upwards if f dash of x decreasing on this interval. Second derivative test for convexity of the curves. By using this theorem, my dear student, to solve convex down or convex up. Let my dear student the function f differentiable twice or second derivative on open interval AB. Then we deduce that f double dash x more than 0 for all the value of x belongs to open interval AB. Then the curve is convex downwards on this interval open AB. Number 2, f double dash x smaller than 0 for all the value of x belongs to open interval AB. The curve convex upward on the interval AB open interval. Now, my dear student, look at important example. We have function f of x has two branches. The first branch f of x equals x squared plus 3 when x smaller than or equals 1. The second 3x plus 1 when x more than 1. Find number 1 the critical point of the function. My dear student, we have function f of x has two branches, x squared plus 3 where x smaller than 1 and 3x plus 1 when x bigger than 1. Find the critical point of this function. Number 2, find the intervals of increases and decrease of the function f. Number 3, find the local maximum and local minimum points of the function. To find, my dear student, f dash of x, we discuss the differentiability at x equals 1. How to discuss, my dear student, the differentiability of the function at x equal 1? F dash of 1 limit when h tends to 0 f of 1 plus h minus f of 1 over h. H more than 0, we find f dash of 1 positive. What do you mean 1 positive? Find f dash at the right of 1 equals limit when h tends to 0 4 plus 3h minus 4 over h equals limit 3h over h equals what? Equals 3. Look at when h smaller than 0, my dear student, f dash of 1 negative, limit when h tends to 0 by substitution about when x 1 is left 1 or second branch 1 plus h for all power 2 plus 3 minus 4 over h. By using like terms, then the answer is 2 plus h equals 0. Answer is 2. Why, my dear student? Look at when h more than 0, f dash of 1 positive equals 3. When h smaller than 0, f dash of 1 negative is 2. What you deduce? Therefore, is not exist. Why? Because f dash of 1 positive not equal f dash of 1 negative. Then 1 and 4 is a critical point. F dash of x, my dear student, from the previous function equals first branch to x when x is smaller than 1 and equal 3 when x more than 1. f dash x equals 0, then 2x equals 0. What you mean, my dear student? X equals 0. Then x equals 0. What is the point is critical point when x equals 0? The critical point is 0, 3. Critical point, we have two critical points. The first critical point 0, 3, second critical point 1, 4. Number 2, look at, my dear student, we have two critical points at 0 and at 1. F dash on the first interval is negative, then the second interval from 0 to 1, f dash is positive. Third interval from 1 to infinity is positive. What you mean? The first interval, the function is decreases. Second interval open 0, 1, the function is increase. The third interval also the function is increase. The function is decrease in the first, increase in the second, also increase in the third. Then f is increasing for all x belongs to open interval 0, 1, union open interval 1, infinity. But the function is decreasing for all x belongs to the first interval negative infinity and 0. Number 3, 0, 3 is local minimum. My dear student, graph of the function. When graph the function or sketch the function, determine the domain and the range of the function. This number 1. Number 2, determine the x and y intercepted of the graph. The first one, my dear student, when sketch the graph or the curve at the first, we determine the domain and the range of the function. Number 2, determine x and y intercepted of the graph. Number 3, locate x values for all which f dash x and f double dash are either 0 or undefined. Locate the x values for which f dash of x and f double dash x are either 0 or undefined. Use the results to determine relative extrema and points of inflection point. Look at this example, very important example. Sketch the graph of f of x equals x minus 4 for all power 3. As the first, what is the domain? What is the range? Equal r. Why? Because this function is polynomial. Polynomial function, any polynomial function, its domain r. Also, its range is r. Then the domain of the function equals range of the function equals r. As the first, domain equal range equal r. The second, what is the x intercepted? What do you mean x intercepted? But y equals 0. Then intercepted at 0, 0 and 4, 0. Then, my dear student, the function intercepted x-axis at 2 points 0, 0, 4, 0. Y intercepted 0, 0 only. Number 3, f dash of x equal x times 3 multiply bracket x minus 4 for all power 2 plus 1, 3 multiply x minus 4 for all power 3 equals 3 multiply x minus 1. Multiply x minus 4 for all power 2. Find f double dash 4 multiply x minus 1 multiply 2 multiply x minus 4 inside bracket plus 4 multiply x minus 4 for all power 2. Answer is 12 multiply x minus 4 multiply bracket x minus 2. Critical point, f dash x equals 0. What is the value of x? My dear student, x minus 1, x minus 4 equals 0, then x equals 1, also x equals 4. Find the critical point. When x equals 1, the critical point 1 negative 27. When x equals 4, the critical point equals 4, 0. We have two critical points, 1 negative 27, 4, 0. Look at, my dear student, we obtain the table. First row x, second row f dash of x, third f of x. We have two critical point 1, and at 1 x equal 1, x equal 4. F dash, the sign is negative in the first interval, second interval positive, third interval positive. The function in first interval from negative infinity to 1 is decrease, has minimum at x equals 1. Second interval, the function is increase from open interval 1, 4. From critical point, third interval from 4 open to infinity, f dash of x is positive, then the function is increase. Point of inflection, we use f double dash of x equals what? Equals 0. Find the value of x when f double dash x equals 0, then we deduce that x equals 4 or x equals 2. We obtain another table from x, f double dash and f of x. We have two values of x, 2 and 4. We have three intervals, negative infinity to 2, 4, 4 infinity. The first interval, f double dash of x, we choose the number less than 2 as 1, and we find f double dash of 1 is positive, then the function is increase. Second interval from 2, 4, we choose the number belongs to this interval as 3. We find f double dash of 3, we find it is smaller than 0 as negative. Also, my dear student, from the last interval from 4 to infinity, we choose number more than 4 as 5, and you find f double dash of 5, we deduce that f double dash of 5 is more than 0 or positive. Then the first interval increase, the second interval is decrease. My dear student, the first interval is increase, the second interval is decrease, the third interval is increase. We deduce that, my dear student, the function is decreases as negative infinity to and union for infinity, and decreasing from open interval to 4. My dear student, by the end of the lesson, we studied how to sketch the curve by using steps. The first, determine the domain and the range of the function. Number 2, determine inflection point as f dash x equals 0, then find the value of x. After that, my dear student, we find f double dash of x and determine the curve intersect x-axis by using y equals 0, intercepted y-axis by using x equals 0, and intercepted x-axis by using y equals 0 to find more points to sketch the curve. When the curve is graph, we use critical point, inflection point, point intersect x-axis, point intersect y-axis. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.